Right now, I want to teach you how to use the charts that are found in the back of your book. On the back cover of your book, you'll see positive and negative z-score charts. In class, I will give you positive and negative z-score charts for the test. We will be using the positive and negative z-score chart kind of rest of the term almost every day. So in class, I have a class set that if you need them, I will give them to you. If you have your book, then you can just look them up in the back. They're also on the insert that if you pull out in the middle of the book, if your book still has the insert in it, you'll find the positive and negative z-score charts there. And they're also located in the back in the index area where the charts are. You'll find positive and negative z-score charts there. For the purposes of our discussion today, I have pulled them up. They are the positive and negative z-score charts here. This is positive and this is negative, so it looks very similar to this. Okay, so to start off, this is a normal distribution, and when I say it's a normal distribution, what I mean by that is that the total area under this kind of arc, which doesn't look quite like this picture does. I mean, if you look at this picture here, you'll notice that this one kind of tails out left and right. That just basically means it goes on forever. My picture that I have here for you does not flare out that way, but it should, and I just can't do it with my little simple program I have here. So if you recall that for a z-score, we had kind of in the middle here was 0. All right, so 0 was going to be kind of our point in the middle, okay? And positive z-scores are on the right-hand side, and negative z-scores are on the left-hand side. Now, if you remember the empirical rule told us that 68% of data would lie within one standard deviation. So what we're saying there is that 68% of the data would be between one standard deviation below the mean and one standard deviation above the mean. So on a graphical representation, what that would look like is that we would have 68% of the values would be kind of in this shaded area here. So, shoot. Well, it's okay. So, I mean, I don't want to waste all my time doing this thing, but that this area here would be 68%, and we could erase this portion. This portion's not part of it. Okay? So what we're saying there is that this portion in the middle is 68%. All right? So what I need you to realize is that if this area in the middle is 68%, then the area on the outside, which would be this area here, the area here, this area, and this area, collectively, these two pieces would have to be 32%. If 68% is in the middle, if 68% is in here, then 32% must be on the outside edges. All right? So collectively, the outside must be 100 minus 68, which is equal to 32%. All right? So the total little blue area here is going to be 32%. Now, if the total blue area is 32%, that would make each slice of blue to be 16%. Simply taking the 32% and dividing it by 2, and that would make each little piece here, this side would be 16%, and This side here would be 16%. And that's what we would get. Now, what that would mean is that if I were to erase all of this area, and I would just want to concentrate on this area here, from here back, and do all of this area, right? All of this shaded area. All right. If I wanted to do all of this, that total area would be either, you would think about it in one of two ways. Either you would do 16 plus 68, which is this portion is 16, this portion is 68, and you would get 84 that way, or you would do 100 minus 16, which is the area that you don't want, keeping in mind that the whole thing is 100%. So either way, you would get that this area is 84% or 0.84. Okay? Now, how does this work on a z-score chart? So if I go to the positive z-score chart, it's the area to the left of this z-value here. If I go to 1.00, which is one standard deviation, 1.00, and that is 0.8413, that would tell me that this area here is in actuality 84%. Okay, so it's actually, if we do this, it is really just this total area would be, so the actual answer is 0.8413. Okay, so what we have to learn to do is, how do I learn to take and use this chart to find various values? So going back to the other page, what I'm going to do is create for you a few different graphs and show you how to do it. So if I'm trying to find the area, let's say I'm looking for the area to the left of this thing here. So we're looking for this area here, and let's suppose for a minute that this value here is 2.44. If I'm looking for the area to the left of 2.44, I go to my little z-score chart, and I'm going to go down to 2.4, and then I'm going to go across the top to 0.04. So it's going to be 2.44. And so I'm going to go over to 2.44, and this becomes kind of my answer, 0.9927. That becomes the value for this total area here. So that total area would be 0.9927. So the answer for this one would be 0.9927. If I were looking for the area left or to the left of 1.25, if I'm looking to the area to the left of 1.25, so say I'm searching for this area here, I simply go to my chart, I find 1.2, I go over to 5, and the answer is 0.8944. And so then I would write the answer as 0.8944. Okay. Now, we don't always look for the area to the left. Sometimes we look for the area to the right. And when that happens, let's say that we have our same value, 1.25, and we're not looking for the area to the left, we are now looking for the area to the right. So we're looking for this little small piece here. And what would that piece be? Okay. Well, we would know, though, that if this area is 0.8944 and the whole thing is 1, that this portion here would have to be, 1 minus 0.8944, which is 0.1056, if you just subtract that from 1. Now, we could get that if we make an observation. If I go to the negative chart and I look up 1.25 on the negative chart, here's negative 1.2. This is 0, 1, 2, 3, 4, 5. If I look up 1.25, I get 0.1056. And what you'll notice is that's exactly the same thing that we came up with. And that means to find the area of a small area, small meaning less than half, I'll use a negative chart, and if I'm looking for a big area, I'll use a positive chart. Okay, so like for example, if I came here and said, what's the area to the left of, negative 2.54, then to do that, I simply go to my negative chart, negative 2.5, go over to 4, and you get 0.0055. And that would be the answer. 0.0055. I think that was it. 2.5. Yeah. Now, if we asked the area to the right, let's say I was looking for this area where it's a big area. If I'm looking to the area here, and this is 2.05, negative, all right, then what you do is you don't go to the negative chart, and the reason why you don't go to the negative chart is because this is a big area. Big area means more than half the graph. So don't go to the negative chart. At this point, we would go to the positive chart, and I would look up 2.05, and I would get 2.0012345.9798. Okay, so you'd get 0.9798, and that would be the answer. Okay, again, if you did go to the negative chart and you looked up 2.05, you would actually have to subtract that number from 1. Okay, so big area used a positive chart, small area used a negative chart, and then make sure you look at section 6 or video 6.3 and 6.6.5 for examples of how we're going to use the z-score. Thank you.